Suppose it is an electrical wire, and from this electrical wire some current is flowing. What direction the current is flowing, that I will not discuss now. The current is flowing in a particular direction. When the current is flowing, what will happen? The magnetic field is produced around the wire. So here is a magnetic field is produced. When the magnetic field is produced around the wire, we wish to find out how much magnetic field is produced. You see, whenever you do anything, the first question comes how much. When you purchase something, it is how much. Similarly, when current is flowing, the magnetic field is produced. So the first question comes in the mind, how much magnetic field is produced. So we select a particular point. Suppose I select the point P. So at the point P, you want to find how much magnetic field is produced. So that magnetic field at the point P we can easily obtain by using Biot Savarts law. One more thing, when we got a wire and from the wire the current is flowing. When the current is flowing, can we directly find out the magnitude of magnetic induction due to entire wire? No, we cannot find out the total value of magnetic induction value for entire wire directly. We cannot do that. For that we need to select a small part of the wire like this. Here I can select the small part of the wire. By using the small part of the wire, now we will obtain the expression for magnetic induction due to small part of the wire. Then we can extend that formula to the entire part of the wire. For example, you are arranging a party. Suppose 100 persons are coming. So can we directly calculate the cost for the 100 persons? No. First we have to calculate the cost for the one person, then multiply it with the 100, then you will get the entire cost for the 100 persons. Similarly, here we cannot calculate the magnetic field directly for the entire part of the wire. First we have to take a small part of the wire, then obtain the expression for magnetic induction for that small part of the wire. Then you can extend that formula to the entire part of the wire. For that, here I have selected the small length, very small length. We call it a small element of the wire. So that small length is called small element. So let us call this small element as a DL. So this is the length DL we selected here because it is quite small. Therefore we call it as a DL. Now current is flowing through the DL. Current I is flowing through the small element DL. And the magnetic field produced all around it. So let us select a particular point. Let us say this is the particular point P here. So why I selected here, I can select within the region of influence. You cannot select somewhere like this. Wire is here and you are after 3 meters you are selecting the point. That will not work. You have to select the point such that the magnetic field is easily realized by the compass needle. Compass needle will show the deflection. Within that region you have to select the point P. So let us select the point P here and now join the center of the element to the point P. So this is the way we have selected the center of the point element to the point P. Now the magnetic induction depends upon length DL, the elemental length of DL. So if you double the length, suppose I select the DL, now DL. So what is the length? Length AB equals to DL plus DL. The length has become twice. So my question is that will the magnetic induction will also increase? Answer is yes. When the length of the wire increases, then magnetic induction value also increases. So according to Biot Savarts law, the magnitude of magnetic induction will be depending upon the length of the wire. As the length of the wire increases, the value of magnetic induction also increases. So magnetic induction, the magnitude of magnetic induction directly proportional to length of the element AB. as the length of element AB increases, then the value of magnetic induction also increases. So this is the first factor. This is the first factor of Biot Savart law. In the statement of Biot Savart law, the first factor is that the magnetic induction directly proportional to length of the element dl. Now, second thing is current. If I increase the value of the current, here the current is how much? I. Now, if I increase for current I, what is the magnetic induction? dB. Now, if I increase the value of the current, suppose I double the current here, will the magnetic induction will increase? Yes. As the value of the current increases, the value of magnetic induction also increases. So, the current, the second factor is that dB directly proportional to magnitude of the current. Now, one more thing, here was the point P, and this is the angle between what? Angle between DL, and let us call this point as a O. This is the O, OP. So, angle between DL and OP is equals to theta. So, if theta is changing, then magnetic induction will also change. So, the magnetic induction depends upon value of theta. If the theta is changing, then the magnetic induction will also changing. That we take the sine theta here. So the value of, according to Biot Savart law, it is telling that the value of magnetic induction at the point P will depend upon theta, that is directly proportional to sine theta, because sine 0 equals to 0, sine 30 equals to 1 by 2, sine 45 equals to 1 upon root 2, and sine 90 equals to 1. That means as the theta increasing, the value of sine theta is also increasing. So here, according to Biot Savart law, the value of magnetic induction depends upon the value of sine theta. As the sine theta increases, the value of magnetic induction also increases. That means the smallest value of magnetic induction is for theta equals to 0 degree. When theta equals to 0, everything is 0. And when theta equals to 90 degrees, you will find the maximum value of magnetic induction at the point P. So the magnetic induction will, the value of magnetic induction will depend upon the sine theta. So dB directly proportional to sine theta. Now one more point, that point P was placed here, and let us call this distance, that is the OP. Length OP is equals to, let us say, 1 meter. Now we will extend little bit the distance. Suppose this is let us say 0.5 meter. Now so another point P1, that is 0.5 meter. Now another point, let us say further we increase 0.5 meter, that means so P1 is at a distance of 1.5, and let us say P2 at a distance of 2 meters. So what is the length OP? Length OP nothing but 1 meter, and length OP1 equals to 1.5 meter, and length OP2 equals to 2 meter. I selected meter here to make you understand. It may not be meter, it may be centimeter, or it may be mm. But to make you understand, I just selected here the meter. So which point is very close to the DL? The point P is very close to the DL. That means it is near to the element DL. When the point is near to the element DL, there is a magnetic induction is larger. As you are moving away from, the element DL, the value of magnetic induction also decreases. Not only decreases, but decreases with a larger amount. Okay, so we can say that the magnetic induction inversely proportional to square of the distance between the point P and the point O. O is selected at the center of DL. So the magnetic induction is inversely proportional to square of the distance of the point P. As the distance increases, the value of magnetic induction will decrease. So these are the four factors will decide the value of magnetic induction at the point P. Now let us summarize all the 4 points. So we had first dB directly proportional to I and dB directly proportional to dl and dB directly proportional to sin theta and dB inversely proportional to square of distance, that is length OP. This distance is equals to R. R is changing, then value of the magnetic induction is also changing. So these are the 4 factors. Now we will combine all 4 factors to make one single equation. What is that? dB directly proportional to I dl sin theta upon R square. Now to remove this proportionality symbol, we create here a constant. We introduce a constant here. So dB is equals to K. K is a constant of proportionality. So K into I dl sin theta upon R square. K is a constant of proportionality. Now K will depends upon the 2 things. One is a system of measurement, that what type of system you are using. Are you using CGS system, MK system, SI system? What type of system you are using? On that system, the value of K depends upon. The value of the K also depends upon medium where the point P is situated. What is the medium between the conductor and the point P? So where you have placed it? Have you placed in the water? Have you placed in the gas? Have you placed in some other magnetic material? Where did you place this point P? So the point P plays in certain medium. So the magnetic induction will depend upon